No se abajo mi mouse, soy bien imbécil con eso.
Hey everybody, just about to get started here. Some new software that we're using looks like it's all going to work out well for what we're doing. I haven't quite figured out all the buttons, even though my testing was a little bit different. Okay. Okay, thanks for joining our January hangout. I'm Chris Beekler, co-founder of the pfSense project, and we be going over some project news today, where development's gone in the last month or so, and then I've got a tutorial on some Firewall and NAT fundamentals and related concepts. Some news from the last month, our store is now live, store.pfsense.org. We've got stickers and shirts, pre-installed USB flash drives, and 3 different hardware platforms available at the moment, with more to come. It's a good place to get swag to support the project, and also to get hardware that you know is going to be fully tested in every way, and tested in advance before new releases come out, just to make sure that there's not anything specific to your combination of hardware that may not play nicely with a certain driver or something along those lines. So that's it's the best way to have the most reliable hardware possible for your pfSense systems. And we also launched a new website, a redesign over the weekend on www.pfsense.org, and some minor content updates there as well. We'll be adding some more things there in the coming months. The 2.1 book that y'all have access to via the site it was updated a couple of times in January, and in addition to PDF, we now have EPUB and MOBI formats available. I don't know how many people have tried out the EPUB and the MOBI yet. I have read through the bulk of the MOBI on my Kindle, and it seems to be.
I don't know. John's here.
Working well.
John, can you help with that window?
I thought I had everybody.
Yeah, I got a cold. You don't want to sit on it. Tell me what have you... Never. I try not to.
Not on a Mac.
I try.
Okay, sorry about that. I'm not sure how I got unmuted. let's see, where was that? Oh yeah, so if you have an e-reader of sorts that works better with EPUB or Mobi, if you can check out those formats and let me know if you see any issues with them. By and large, they seem to have come out very well. And as always, there's just a directory after you log in at portal.pfSense.org /members, and there's a book link there, and that's where you'll find those. In the past, really few months or so, we've been HTTPS enabling our websites, and we've done that a lot more over the past couple of months or so. Almost all of our websites are at least optionally HTTPS. If you have the HTTPS Anywhere browser plugin from the EFF, that makes sure that you get redirected to SSL for any of our HTTPS enabled sites. A lot of them are HTTPS by default now, like the forum and Doc and Redmine and a few others. But not necessarily all of them just yet. We'll probably have that done before too long now. Just with all the craziness going on the internet these days, it's nice to have at least some level of assurance that you're actually going where you think that you're going. Things that are going on in development recently. 2.1.1 release is coming soon. We've got some bug and security fixes
I have my
in that.
personal one up earlier, but I don't get it. Oh, sorry.
The security fixes are three FreeBSD advisories. One of them's on BSNMPD.
Let me back in. Wow.
One of them's on NTP,
No,
and
wait.
another on OpenSSL.
So now I'm getting the message, DMK mail is temporarily unable to access your contact. Look at that.
Yeah, I'd say there's.
Of those three, the BSNMPD one is something where anyone who can query SNMP, if you have it enabled on your system, which would only be via LAN by default, could crash it and potentially execute arbitrary code. There's not that I've seen any kind of public exploit for it, but if you run SNMP open to the internet, you should either close that off or via firewall rules, or disable it, or upgrade to 2.1.1 snapshot to be on the safe side. The NTP fixes are related to the NTP reflective denial of service attacks that you've probably seen in the news recently. It's not really something that can hurt your machine, except in the case that you can actually be using a lot of your outbound bandwidth to attack somebody else. So they'll basically use a relay to send a denial of service attack to somebody else. If you have NTP open to the internet, you probably don't want to be, and you should probably just firewall it off. But there is also a patch in the package system for 2.1, so you can patch it without actually upgrading to 2.1.1, or you can alternatively upgrade to the snapshots of 2.1.1. They are available now for download, snapshots.pfSense.org. And there is a 2.1.1 board on the forum, so if you're trying those out, that's the place to go for anything that's specific to 2.1.1 at least. And there's a pretty significant list of relatively minor changes at the link at the bottom there. You'll be able to download slides afterwards and go to click on these links there to get there more easily. And 2.2 release is also under development right now. the biggest change is the getting up to FreeBSD 10.0 base, which was just 10.0 was just released this week. It has an SMP scalable PF, so it's not giant locked to a single CPU. So you can, in a lot of circumstances, get significantly better scalability through the firewall. Not so much for maybe smaller networks, but the ones that really push a lot of traffic that will help considerably. There's much improved hardware support in general in FreeBSD 10. A lot of the latest things that you can get new that out now that aren't necessarily supported in the 8.3 base that we use on 2.1.x releases is generally supported there. And the wireless support as a whole has really made a lot of progress. There's a whole range of improvements in the drivers and the whole wireless system as a whole. It's going to require some refactoring of our code and how we handle things, but that's going to be a much appreciated change, I think, once we can get it out there to people. We added enhanced Capture Portal HTML page management, so it was kind of you'd have to manually hack the config before to remove the HTML if you wanted to revert back to the default, and it wasn't necessarily easy to see what you had in there, and that we've made that a bit friendlier and easier to deal with. It added an option to whether or not you want to prefer IPv4 or IPv6 for firewall-initiated traffic. And that's only for traffic that's actually initiated by the firewall. Which one your clients inside the network choose is up to the client. The firewall can't influence that. There are some cases where people's systems think they have IPv6 connectivity, but they don't actually, so then they can't hit certain sites like our update site or things like that where we're dual stack, and by default it'll prefer v6, but if it only looks like you have v6 connectivity, which you really don't, then that would make that fail. So we had that option for those who are in that kind of a situation. The one-to-one NAT entries can be reordered now as well. That's their first match wins, so there were some unusual but happen from time to time circumstances where those need to be reordered. The hybrid outbound NAT is a combination of the regular automatic outbound NAT that we have and the manual outbound NAT. So normally now, if you switch from automatic to manual, then you have just one or the other. You get the automatic rules generated, and from then on out, you have to manually manage everything. This will let you add. You can keep all the auto-generated NAT rules, but then you can add some user-defined optionally that will override the automatic ones, and then it's still processed through the automatic rules. I can make things a little easier to deal with if you have some more complex outbound NAT needs. And there will be quite a bit more to come. Some of that yet to be determined, some of it that's not fleshed out well enough that I can really get into it today. But in future months, we'll talk about it some more. Just checking the chats there. I mean, I guess most people obviously can hear me okay. It does seem to be recording in the meeting.
Good.
Oh, did that unmute me, everyone? Okay, thanks, guys. I didn't realize I was talking to myself. I didn't know what button I hit, apparently. Okay, well, once this machine decides it wants to log in here. Usually I have such flawless luck with demos. This one today is just not going so smoothly. Yeah, tutorial gremlins indeed. Yeah, are you kidding me? In this case, it really might be the Mac. To the guys in chat. Oh, man. Yeah, for the most part, remote desktops works okay on the Mac, but not nearly as well as Windows. I downloaded the new Microsoft one out of the App Store because supposedly it's new and improved, but well, heck, we can't even get that one to get this far, and then this one just kind of sits there.
What's the N suffix on Windows 7 Ultimate? I've not seen that before.
What is that? It's one of the. Gosh, they got so many different ones. I'm not sure offhand what that stands for. It's one of the different volume licensing programs. It's an MSDN.
Oh, got it.
MSDN license that we use for dev.
Got it.
Testing purposes.
Yep.
Huh. Well, that's bizarre. Well, let's see, what else can I do? I can just log into this VM from the other side. Man, this worked not an hour ago. I don't know what happened. I moved my laptops to the other room and all heck broke loose, apparently. Okay. Okay, so we just have a basic, more or less out of the box configuration here. It's got some allow all rules on WAN that are necessary because I'm coming in from the WAN side of it since I couldn't get over to the LAN. And it's got the default LAN rules on it. So just starting with the default rule set, you have those gone, and you have block private networks in place. This is not the exact same VM because it's in a fully virtual network on the other side. Okay, so I'm not going to apply that because I'm going to get locked out if I do. But the default WAN rules are just the block private networks. So any network that is in the RFC 1918 reserved private network space that's coming into you on WAN, so that would be traffic that's sourced out from the internet, is not going to be allowed in by default. The second rule is the block bogon networks, and that's kind of similar. There's a list of IP subnets that are reserved and not assigned. The not assigned part of IPv4 is close to nil, but the IPv6 list, if you do have IPv6 enabled, is significantly larger.
And the reason for blocking 1918 on WAN, that's because it can only mean shenanigans. Is that what that means?
Yeah, because there's no reason for any kind of legit traffic to ever come through in from the internet if it's sourced from those networks.
Right.
Now, if you're in a situation where, like some people do, where this is not actually your edge firewall, your WAN is not actually an internet connection, you have a private network there, and then maybe you have other private networks behind it that you're routing through there, then in those cases you'll want to turn that off. But
yeah. Or would it make sense to add a pass rule in front of it where you would pass just the specific subnet, say you were running like a 172.16, but you're not running a 192.168, nor neither a 10 dot?
They're not reorderable, actually. So if you do need to reorder it for some reason, you can create an alias. We do have a feature request ticket open on that. I don't think it's targeted for 2.2 at the moment, but you can always just create an alias of the RFC 1918 networks, which I'll actually show later, and then you can disable that function and then add your own block private networks rule. Yeah, it's, on some ISPs. Like some cable providers tend to use private IP space for things like their DHCP servers or things along those lines. And then on cable, for instance, you're on a gigantic broadcast domain. And so you're going to get, depending on how big your area is, you may get just thousands and thousands and thousands of other people's DHCP responses and clog the heck out of your firewall logs. So that's another reason that you might want to disable that and create your own rule that doesn't actually log, because this follows the logging policy of the default deny rule. So out of the box, everything that hits that will get logged. So that in certain circumstances can lead to a completely useless firewall log full of junk that you don't care about. In that case, disable it and add your own rules.
Right. It'll be like Grandma's Internet Explorer toolbar set. Sorry, I couldn't resist.
And then the default LAN rules, there's 3 there in 2.1. The very first one is an anti-lockout rule that automatically allows access to the LAN address on the ports that you're using for management. So that was added after people a lot of times started messing around. They didn't realize, hey, if I don't allow access to my management, I'm going to lock myself out of the firewall, and it won't be good. So we added that there. That's not necessarily a good idea to leave your management open to the entire LAN, depending on what kind of network you're in. On a home network, no big deal. A lot of small businesses don't care. But in a lot of mid to larger shops, you don't want to leave your firewall management open for any employee to attempt to get in there and poke around, even if they don't have the login or anything. And then the IPv4 default LAN ANI rule is the same as it's always been, and it's kind of a default that every more or less firewall router has adopted. Anything coming out of LAN is good, and anything coming into WAN is bad. That's basically the logic of the default rule set. And then for 2.1, we added the same thing for IPv6. Now that's what most people want, but it's really not the most secure possible option. If you can significantly tighten down what you're allowing outbound, you can save yourself a good deal of headaches. Doing things like only allow SMTP outbound from your mail server. That way, if your machines get infected with spam bots, your firewalls just drop in the traffic. Something that we see quite a bit in hosting environments where these companies have customers who aren't necessarily keeping their Joomla or whatever other security hole-ridden CMS up to date, and it gets popped. And then one of the things that the script kiddies love to do with those broken servers like that is put in some kind of denial of service tool, so then they're chewing up your bandwidth to go beat up somebody else or spam somebody else or something along those lines. And if you can restrict that kind of traffic, if you know that your web server should not be sending out traffic straight to the email, straight to the internet, or if you know they only need a very limited number of protocols or ports, if you can restrict those things down, then you can prevent yourself quite a few headaches, especially in the case of like denial of service bots that are trying to get outbound. So that's the default rules. Oh man, it messed up all of my images. Okay, so here's how the order of operations of the NAT and firewall rule processing works. I also did the packet capture in there. Not that it has any relation directly to anything that we're talking about here, but if you're looking at packet captures to try to troubleshoot what's happening, it's important to know where that kind of ties into the whole process. So in this particular diagram here, this is illustrating what happens from LAN to WAN. So here's your things on the LAN interface here, and on the WAN up here. So then you get a client machine inside your LAN that is going out and talking to an internet web server. So the first thing that hits on the LAN is the packet capture, and in this instance, it's going to skip NAT because NAT happens on the outbound direction of an interface, and this traffic's not actually leaving LAN in this case. And it gets evaluated by the firewall rules. If the firewall rules pass it, at least in this simple LAN-WAN config, then it's going to egress the WAN interface. At which point the firewall rules on WAN have nothing to do with traffic going outbound. It'll hit the NAT, which will translate the source IP, and after all that's done, and at the point that the traffic is put on the wire to send up to your ISP, then that's what you see if you capture on WAN is exactly what's going out to there. Now, I'm keeping things simple in this point to apply to the most possible people in their deployment scenarios. It actually is possible to, for instance, use firewall rules out on WAN if you're using floating rules, but that gets way more complicated than what we have time for in an hour today.
But your main thrust there is that you could have an egress policy on WAN or one particular WAN link using one of these more complicated setups you're describing.
Yep, yeah, you can use floating rules for that because then you can define the direction of the rule and which interface it goes out on and everything else. But the bulk of people stick with the interface-based rules, like in this case just WAN and LAN, and don't bother with anything else. So that's in that scenario, that's what happens. That's the order that things are processed in. So yep. The firewall rules are evaluated before it's NATed, and NAT is the last thing that happens before it gets put out on the wire.
Yeah, great.
And then in the opposite direction, if you have a client out on the internet that, let's say, is trying to get to a web server inside of your network, so it first hits the spot where the packet capture ties in, so you're seeing what is coming in from the internet before you do anything to that traffic. Then it hits your NAT configuration, whether it's a port forward or a one-to-one NAT, and then that translates the destination IP to whatever the internal IP is. And then the firewall rules are evaluated, and if that traffic is passed, then it goes out to the destination host. And again, this is a bit simplified in that you can, if you're using floating rules, you can actually filter on the outbound traffic. And if you want to do manual outbound NAT and source NAT on traffic leaving the LAN, you can do that as well. It's not a very common thing that you would want to do. This is 99% of scenarios at least will look like this.
Chris, can you if I don't want to interrupt your flow, but if this would be an okay time to describe the difference between, or maybe the role of manual outbound NAT versus automatic NAT. I think automatic NAT is self-evident, where you're, substituting your WAN IP, or your private IP with the public WAN IP and a new port number. But what's the role of manual NAT, and when is that relevant?
Yeah, that's actually the next thing I was going to go to.
Oh, great.
Okay, so no, that's right. So under Firewall NAT, the outbound NAT is what we were showing in that little diagram that we just had up there. If you have the automatic outbound NAT enabled, it will translate any internal network subnet that it has to the external IP of the WAN where it's leaving. So what you end up with is, in this very simple case, you'll have the LAN subnet gets natted to the WAN subnet. Now, if we change this to manual outbound NAT, it will automatically generate the rule set that it's using now, so I can better illustrate exactly what it is. So our LAN subnet is 10.0.0.0/24 in this case. And this is the three rules that we would automatically use in the automatic scenario. So there's one rule for ISAKMP for IPsec. So if you have IPsec clients behind your firewall or inside your LAN, it will not rewrite the source port on those. That's what static port is. Normally, the source port on all traffic gets rewritten whenever NAT occurs, and it's slightly better for security reasons. Mostly, it makes NAT a lot easier to deal with, especially in scenarios where you may have a lot of devices that don't use random source ports, like SIP phones is a good example. They usually use source and destination port 50. And once you translate that out to a public IP, there's no way to keep track of which phone's which anymore. So by randomizing that, it kind of helps the NAT process. But that does break some things, and ISAKMP is one of those that's relatively common. Most IPsec VPNs today will use NAT if they're the type that mobile users use, so this is not really relevant. A lot of people just delete that rule entirely. The second rule, it just basically matches anything else. If it's not UDP 500 traffic, then NAT it to the WAN address and rewrite the source port. And then the very last rule is for any traffic that's bound to something on the local host of the firewall. Then it automatically translates that to the WAN address. The thing that people use that for the most is generally squid. If they're trying to load balance squid, they'll bind it to 127.0.0.1, and then that NAT entry will take care of that. But in most cases, you really don't need either one of those. So ultimately, you're left with just one rule that just matches your LAN source subnet, and it translates everything to the WAN address. Now, that gives us effectively nothing different than what we would have before. So, for a couple examples of what else you might want to do, the most common thing is if you have multiple public IPs, and we can add a virtual IP just to have something to illustrate. Normally it should be an IP alias or CARP or proxy ARP, depending on the specifics, but I don't want to create an IP conflict on the network at the moment, and I don't have an address handy, so other doesn't actually do anything except make a placeholder. It's not an appropriate type of virtual IP for most circumstances, unless you actually have a public IP subnet routed to you. So now if we go back to outbound NAT, we can add another rule here, and let's say we have, let's say there's some other subnet that's 10.0.10/24, and we want to translate that to that new IP that we just added in. So the way that the outbound NAT works, it's the traffic, it's the interface that the traffic is leaving. If you check do not NAT, that can be if you have kind of a really complex scenario and you're natting things in all kinds of various different ways, and you need to exclude something to not be natted, then that would otherwise match one of your NAT rules, then that's when you would use the do not NAT. The interface is WAN in most cases, because that's the interface that you're leaving. So as the traffic goes out of WAN, then it gets translated as this rule defines. Most of the time, you don't really need or want to get specific with protocol or things like that. And there might be some scenario that you have where you want a certain protocol to get natted to a certain IP and everything else not to. So it can come in handy in situations like that. But for the most part, people generally just want anything from a certain specific source to go out via a certain IP.
We do see pretty commonly people will make that protocol UDP if they're doing static port out for VoIP.
Yeah, that's a good example, Jim. Thanks. And that's the bulk of that. I bet it kicked the filter back on while I was talking. I left block private networks on, so I've locked myself out. Okay. And the firewall rules and the NAT rules are first match wins. So you do have to be careful with the ordering if the ordering is such that multiple rules can match your traffic. So let's say we've got another host here that's 10.0.0.15 or something, and we want that one to go out via that IP. Now, if it were, I hit the plus here rather than here, so the top plus adds it to the top of the list. Or actually, I think I may have duplicated this rule. Regardless, the top plus adds it to the top of the list. The bottom adds it to the bottom of the list. And then you can click on it and then choose where it goes by highlighting the arrow appropriately. But in this case, the traffic from the where did my source IP go? So you have the option of any or network, and if you just want to make it a single address, a /32 is a single address. I made it a /24, so it corrected my mistake of not having a proper network address for a /24 in there and put 0 back. In this case, if you just wanted a single address. So with this order, traffic source from 10.00.10 wouldn't match the first one because that's a different subnet, but then it would match the second one. And since the first match wins and there's no further evaluation, then it would never hit the third rule. So you just got to pay attention to your ordering and make sure that things match in an order so they do the things that you're intending them to do. And one of the things that Jim Pingle mentioned a bit ago is for VoIP, some providers don't work if you do rewrite the source port. Some don't work if you don't. There's not like a standard recipe for making VoIP work with every single possible provider out there. We've gotten the defaults to a point where it works with the majority, but there's plenty of exceptions where they don't want you to be rewriting source ports for at least for RTP traffic. So if your PBX is, let's say, 10.00.100, and we'll make that a 32, and we'll pick UDP here since the registrations and the RTP traffic and all that will be UDP traffic, and then let's say you want to NAT that also to that 61 address that we have in there, and static port, so it does not rewrite the source port for that traffic. Okay, and again, I hit the plus at the bottom this time, so it ended up in the wrong spot. So you can move it wherever you want as long as it's above any other rule that would otherwise match. So in this case, that's the one that would match that device otherwise. So yeah, then that only impacts the UDP. So if it needs to do whatever else it needs to do with TCP, then that doesn't impact that. And you can also specify a destination if you want. If you know that your VoIP provider has two different subnets and that's the only ones that you'll be communicating to, you could always put that in there as well if it was sensible to do so for some reason.
And this is another area where in 2.2 the hybrid NAT will come in especially handy because you can stay on automatic and still add your static port rule, and you get the best of both worlds.
Yeah, that'll really for scenarios like this, that'll definitely make things easier. Yeah, let's say you only wanted to change that one rule, you can delete everything else that you got here. Go back to, we don't have the option here, but effectively you would have all the automatic rules plus the manual outbound. Here we can go to.
So I'm sorry, I don't fully understand what's the ugly part of the existing setup? Like, what's the thing that you can't do now that the 2.2 outbound NAT will allow?
So it's you can't have a mix of automatic and manual. So you either manually define every single rule, or you let the system automatically define every rule. So in 2.2, you can actually create mappings down here and select the mixed mode, and then your custom defined mappings will match first. Mm-hmm. And then if it doesn't match that, then it'll go through the automatically generated outbound NAT rules.
I see. So the three outbound NAT rules that you were showing before the example, those you wrote by hand?
Yeah. Well,
okay.
Whenever you initially switch, so I'll delete this just to show that again, and switch back to automatic. So whenever you switch from automatic to manual and you don't have any mappings down here, it automatically creates the ones that it was using automatically. Now with a
So if you
simple
did
LAN
nothing from this
WAN,
port, it would be the same as automatic outbound NAT. Is that right?
yes, yeah.
Okay.
Except that it would not pick up network changes. If you were to add an interface, it wouldn't add more rules here,
I understand.
where automatic would pick that up.
I see.
Yeah.
So you'd have an
That's-
ugly process of going back to automatic, going back to manual, and then reinserting all of your custom rules, for example.
Yeah, or going back through and just editing them. Usually when I run into a situation like that with a customer, I'll do something like, okay, well, you have 10.000/24 here, but
Yeah,
you know what?
change
There's
to 16.
no harm in overmatching. Let's just
Yeah,
make
right.
it a /8.
Yeah.
And then a 10 dot anything will get added outbound.
Yeah. Yep.
So that's usually what I do when I run into that kind of situation.
Yeah, that's great.
But yeah, this can get really, really, really long if you have a lot of interfaces on the system and a lot of VPNs and things like that. I mean, we're routinely on systems that wherever you switch them over to manual from automatic, you may end up with 50, 100, 200. I mean, it can get really, really long on complex systems that have tons of VLANs and whatnot.
And you can use aliases there too, so those are easy to clean up, but it's still ugly.
Yeah.
And on a system processing cost side, I've often wondered this. So so I guess this applies equally to outbound NAT or just firewall rules in general. I've often wondered about, if you have, let's say you've got a block list, and then, let's say you've got, every single, you have 50 rules before that get evaluated before it hits the rule that gets past 99.9% of the time. Are you effectively, increasing the latency in that flow because of the processing cost of doing 50 rule comparisons before you hit your eventual pass rule? Or in this case, your outbound NAT scenario, if you have 500 things or 50 outbound NAT rules that have to get applied before it hits the one that's in fact matching.
There is a difference between 1 and 50, and probably not that much. If you're talking about the difference between 1 and 200 or 500 or 5,000, then yeah, I mean there is some additional processing involved that increases latency through the system for the more rules that have to be evaluated. Mm-hmm. It's not generally enough that it's that much of a consideration for in most setups. For ones that deal with much larger volumes of traffic, then that's a good practice to order them in a way that the most popular stuff matches first, so you don't have to evaluate through potentially 1,000 or more other rules to finally hit the one that's used the most.
Yeah.
And that's a place too where the aliases can help. It's faster for it to do a lookup of an IP in an alias than it is for it to run through an equivalent set of rules because the tables are hashed in a different way.
I see.
So, and again, you have to get to a pretty sizable rule set before that would become a factor. Mm-hmm. But judicious use of aliases and keeping your rule set simple, and yeah, you can mitigate most of that, if not all those concerns.
So in other words, if I have 10 rules, of let's say I've got a bunch of abusive IPs that I want to just categorically block, for example, and there's 50 of them, it would be faster to, put them into a rule that, let's say I couldn't cite or summarize them, I just have to enumerate them one off. So if I just put them in a rule and then add that rule to the top of the rule set, that's going to be a faster evaluation than if it has to evaluate, say, 50 rules rather than one rule with 50 aliases. Is that correct?
Yeah. If you have an alias that has 50 separate host names, it would process it faster than 50 separate rules because of the way it can do the lookups and tables.
Gotcha.
At least from my understanding, anyway.
Yeah, interesting.
Yeah, I believe that's right. It's also a heck of a lot cleaner because if you just create like a bad host's alias is what we see a lot of people doing, and then just if somebody's just doing something crazy, you just want to cut them off, just drop that IP in the bad host, and then some people end up with dozens or more, hundreds or of addresses in there. And if you had one rule for every single one of those, it would be a real nightmare to try to manage your firewall rules.
Yeah,
and it's always a good idea to make as much use of aliases as you can to keep your rules as short as possible, because it's just easier to manage that way. It's easier to look through and kind of audit that way. And you really have a better grasp of what you're actually allowing and denying if you have a much smaller set of rules to look through, so less chance of human error.
So would it be an accurate statement to say, obviously the latency that's introduced by adding, say, 200 or 50 or whatever, rules before the eventual pass rule, that's certainly going to add some latency. But is it, and obviously latency can affect total throughput, especially if you're, TCP or something like that, and you're dealing with congestion control window, as a limiting factor. Obviously you introduce some latency, but do you effectively limit throughput, or are you essentially evaluating the rules in a multi-processing kind of fashion where the second packet is having its rules evaluated sort of in some sense in parallel or slightly overlapping in terms of the time scale, where either due to superscalar architecture or explicit MPP, are you essentially processing packets in parallel, the rule sets in parallel?
That's one of the areas that's going to improve previous D10, because there's not there's less locking there, and so multiple CPUs can kind of handle traffic along those lines. Generally speaking, the amount of latency that you're talking about adding, and the difference between matching the first rule and matching the 2000th rule is less than a millisecond. So, I mean, compared to the traffic the latency that's inherent in just getting pretty much anywhere on the internet, it's kind of a drop in the bucket. But the scenarios where it really matters is if you have some kind of high scale environment where there are tons of people opening bunches of connections to your web server or your mail server, or we got some customers who run game servers, things along those lines. If you have a lot of connection churn and really high rates of new connection per second establishment, then that can really limit your scalability. Where on your typical business network, it's not that big of a deal.
But you're also not going to run into a CPU bottleneck where you're effectively at something below your link speed, that you're going to be essentially running into either some kind of a processing bottleneck in terms of getting that packet out the door, having the next one waiting in line, so that obviously the latency point you make is an excellent one and understood. But do you end up running into, like let's say you're on an embedded platform like a Socras or a LANer or something like that, do you effectively run into bottlenecks in terms of CPU processing, and in that scenario where you've got even a reasonable number of rules like 50, et cetera, per packet? You do become unable to meet your 100 your 100 megabit link speed, or let's say that you want to do a policy on your Wi-Fi, and so you're connecting your Wi-Fi to a separate LAN, or to a bridged port or something like that, and you're trying to get 802.11n or 802.11ac to go through a GigE port on a software policy. Do you start running into CPU limitations in that kind of a scenario, or are you really still? Is it really still?
Generally speaking, no. I mean, in a normal circumstance, in your typical office or home environment, your CPU, especially if you're at on something like an Alex that's pretty limited in performance, you're gonna hit the limit of the ability to push data through before you'll really have much measurable impact on what the rules have.
I see.
If you are in some kind of unusual circumstance where you have huge numbers of rules on an Alex and you have a very large number of new connections per second, well, you probably shouldn't be using an Alex in the first place for that kind of load. But yeah, I mean, you would certainly start hitting higher latency through the box as you were evaluating significant amounts of rules. But the only time I've ever actually seen that scenario actually have any kind of real performance impact is much larger scale scenarios where there's many new connections per second, lots of active connections. Hosting environments of various kinds is usually the where we see that kind of thing.
Yeah, that's helpful. Thanks, Chris.
In regards to the global IP addresses, should I leave the questions until end, or can I ask them now?
It's related to outbound NAT. You're welcome to ask now.
That's my issue. Yeah. So the way you were saying about automatic IP sec pass-through, it's there written. The problem I'm running into is that the existing network was deployed originally has let's say 16 addresses, and they're giving tunnel to you within subnet /24/20 whatever 8, and that's your WAN address is giving to you by ISP as a /16 address between the ISP router and your firewall or router you deploy by yourself. Now there are DMZ ports for sitting multiple firewalls, which are assigned also directly global IP addresses, and using a first available global address as a gateway to that DMZ, which is behind, that DMZ is sitting on the pfSense box. So in that case, if you want to do IPsec from a firewall, let's say a Cisco firewall, sitting on a gateway of the first global IP address available to you, and your WAN address, it's also a different address, then automatic rule won't work. And unless you do a manual rule, that won't work either, because all your NATing will be always using your WAN address.
Right. Yeah. If you have public IPs. Yeah, if you have public IPs behind the system, that's the one scenario where you want the manual outbound NAT, and if you have only public IPs behind, delete all these rules. So if you set the manual and you have no mappings down here, you have no NAT whatsoever, but you still have packet filtering. So yeah, if you're in a data center or some similar environment where you're purely working with public IPs, then yeah, set it to manual. Delete all your rules there, and then you're purely routing. Yeah.
And on 2.2, again, we also have on 2.2 we actually have a no NAT choice like manual, auto, and hybrid also up in the top of the list to make that even easier for people. So you could do manual with no rules or no NAT.
Yeah, but at the moment with what's current. What's going to happen is then if I have a global IP address on a Cisco box, which sits on that gateway with the first public IP address giving to you, and then you're using also the /16 network as a WAN address, then the automatic rule will then outbound traffic going from a Cisco box as IPsec traffic will arrive to the gateway, then will pass the rules at the gateway and will arrive to the WAN interface, and then all the traffic gets translated to your WAN address, which is again different to your WAN address sitting at the Cisco box. So your IPsec won't work unless you do simply one-to-one mapping of the, or you don't do one-to-one mapping, you just use a global IP address which is directly assigned to your WAN interface, and you use an internal address and move that Cisco box onto internal address, and then forward the port and whatever the traffic coming in to your WAN address will be redirected with a specific port to your local address, which will be the IPsec box, Cisco box, let's say. That's the only solution at the moment. Because then the IPsec tunnel won't be able to communicate from each side, as the incoming traffic from the internet is looking for the destination address. of, let's say, the global IP address giving to your Cisco box. So it arrives to your interface. Your interface knows based on the routing tables where to push the traffic into Cisco box. But on the way back, then Cisco box will send the traffic for the destination of whatever the global IP address the source had. And when it arrives, the expected traffic, the firewall permissive rules or restricted rules at the other end are that only from this global IP address is allowed the traffic. So the traffic is changed with your WAN address, and it sends as the traffic coming from your WAN address, not from your Cisco box global IP address. Am I correct? Or
no? If you have manual outbound NAT defined and you don't have a mapping here that matches the source IP of the Cisco, then it will go out with no NAT at all.
Alright, it will go out without no NAT at all, so in that case there shouldn't be an issue.
Yeah. Yeah, just to make sure you don't have any outbound NAT rules with a source that matches your public subnets that you have behind the firewall, and then you'll be good. If you do have a mix of public and private, we could have any number of 10.x examples or subnets, for example, behind this firewall, and if we had other public IPs, then they would, with this particular config, they would just get routed out with no NAT, because there's nothing here with a source that would match any public IP subnets.
All right, that's perfect. Thank you.
Mm-hmm. So the other part of one-to-one NAT, or at least somewhat related to that, is one-to-one NAT. So that takes an external IP and an internal IP, and it directly translates traffic in both directions between the internal and the external. So if we had if we just put a fake public IP there, and if we have the internal IP of some other device there, and destination you'll most always leave to any unless you have kind of an unusual circumstance. So I'll use this as an example for the time being. So with a rule like this, any traffic that comes into WAN that's destined to this IP gets the destination translated to this IP. And at that point, it evaluates the firewall rule set to determine whether or not the traffic will be permitted or not. So like we looked at here, so yeah, that would be more of this scenario. If it was coming in from the internet, it would hit NAT first, which would translate the destination IP to the internal IP, and then it would hit firewall rules. So all your WAN firewall rules, if you're doing port forwards, you'll just create a linked rules. You don't have to worry about it. But if you do one-to-one NAT, just make sure that the destination IP of your WAN rules is always the internal IP, since that translation takes place first before the rules are evaluated. And then the destination that's in here, if you have some need for some reason to only one-to-one NAT something when it's going to a particular destination, then that's what that's for. There's very limited circumstances where that's something that you need to worry about. And port forwards, I went through a decent amount last month, and updated that video's up on YouTube if you guys want to get in a lot of depth there. We're running a little short on time. There's several other things that I want to get covered. So, but the port forward is the ability to redirect traffic as it's coming to a particular interface and matches a certain set of parameters, and the firewall rules that can be added that are automatically associated with the port forward, so it allows the traffic in. So NAT and rules are a completely separate thing. NAT strictly determines how traffic gets translated in a specific circumstance. Whether it's coming into a certain interface, leaving a certain interface, the NAT just tells it when a packet does this is how you translate it. The firewall rules determine what traffic is permitted or denied. NAT in and of itself doesn't do any kind of traffic restrictions or routing or anything like that. I've got a machine on the other side here. I'm just going to push some traffic through that so I can show you a few things. Okay. One of the useful troubleshooting tools for just seeing what traffic is passing and how it's getting translated and things of that nature. If you go to diagnostics states, you'll get a full dump of every connection that's active through the system. Now, since we don't have a whole heck of a lot going on here, there's only 8 connections. But in most real networks, unless it's an abnormally silent network, you'll probably want to use some type of filter expression. So I've got a ping going to Google DNS 8.8.8.8. So let's say you've got a constant ping going to 8888, and you want to see, and maybe it's not answering, or maybe it is answering, and you just want to verify where it's going. So if you just put that in there as a filter, here's the 2 connection states. So this is the NAT piece, and this is just the traffic was permitted. So it sorts from the machine that I'm pinging from is 10.0.0.10, and then your middle IP is always whatever address that it gets translated to, if it's getting translated at all, and then the destination is all the way over on that side there. And if you want to actually kill those states, so say you make a mistake with your outbound NAT and it's getting translated to the wrong thing, then you can kill those states off, and it will generate a new one on the next packet. That's one thing to always keep in mind whenever you're changing firewall rules or NAT rules with basically any stateful firewall that exists anywhere. Those changes do not apply to traffic that is already being passed. So if you may just want to come here and filter and kill states, or if you don't have tons and tons and tons of traffic going through the system where dumping the entire state table would cause a network hiccup, you can just go over here to reset states and wipe the entire state table. And I can break our NAT here just to illustrate. Okay, let's just say I typoed that, and I'll stop that ping. And I'll go to 8844 this time. So I'm not getting any replies to that ping, so where's my ping going? One good thing to check first is go to states, and okay, I'm pinging 8844 this time. And look, this is traffic that's going to the internet, and it should be getting natted to an IP that can actually reach the internet. But you can see there's only the 2 states without any translation in the middle. So what that means is this is not matching any of our outbound NAT config. So if I go back in here and fix that. And it's still not getting passed because the active connection is still going. I still have the constant ping running. But if you just kill those, I immediately start getting responses on the other machine. And if you filter it, you see, okay, now we've got our translation. So it's always a good place to go look and troubleshoot if you're not sure, is this traffic getting passed? Is it getting natted properly? Filtering on the states is a good way to go. If you don't find the traffic in question in the state table, either you're blocking it or it's somehow not getting to the firewall. Maybe there's a routing config issue on the source host in question. It's not actually sending it to the firewall, or maybe your firewall rules are too restrictive and are blocking the traffic. The other place generally to look for firewall troubleshooting, if you go to system logs firewall, this will show you everything that gets blocked by default. It doesn't show you anything that gets passed by default, because that's kind of that would end up with a significant log volume. You may want to enable logging on a per rule basis, and you may want to do that in certain circumstances, depending on what traffic that you're really interested in. And the general way that firewalls behave by default is they block what they're dropping, and they don't log what they log what they're blocking. They don't log what they're passing, which is kind of interesting to some extent. But the traffic that you're blocking, it can't hurt you. The traffic that you're passing is what really can compromise your network. So there's some degree of balance there, depending on what kind of network you have. What's the specifics of it as to what things you want to be logging. It's a good practice to go through, and if you see something like this, where you just have tons and tons and tons of DHCP broadcasts getting blocked, to put in a firewall rule so that noise just doesn't show up. This is the kind of thing that you would see on a cable modem network generally. And then whenever you click on the action over here, it'll tell you which firewall rule actually blocked the connection in question, which that is no longer accurate because it was a long time ago, but this that's reloaded rules as well. We've changed the rule set on the system so many times that the actual rule numbers don't match up to what is there in reality anymore, and we're not actually blocking anything because we've got things basically wide open. But that's the easy way to tell. Okay, why was this blocked? And you'll get the label there. At least if you haven't changed your firewall rules extensively, the rules are numbered, and the numbering of the rules, if you make enough changes to them, will change over time and not necessarily associate back to the firewall log. It's not all that common in your typical production use. And there's also the ability here to do a couple of other things with the IPs in question there. So if you can do a reverse DNS lookup, and then it'll query whatever IP that you're looking at, and there's some IP info and IP who is things if you want to take a look more closely and see where this IP is, what ISP it belongs to, etc. That can be helpful. This is a private IP, so it's just comes up as INA reserved. But if you're looking up a real public IP there, it'll give you some good information on whether or not that may be legit traffic or where exactly it is that it's coming from. And then there's the easy rule. You can add to the block list for easy rule here, or the pass rule for easy rule there. I'm not sure if Jim P is still around. He wrote that. Yeah.
If you choose the block option, it creates an alias or if the alias already exists, it will just add it to it. It's sort of like the bad host alias we mentioned earlier. It will make one of those per interface and apply it in the rules. I think it even puts it at the top of the rule set. If you choose pass, it gets a little bit more specific. It will only allow from that source to that specific destination IP import in the protocol you chose. But it does that with an individual rule rather than an alias.
In the right column here, we'll show you whatever details that we can get from the traffic about the protocol in question. For some, like UDP, you end up with the port numbers over here as the source and destination, and that's really all there is to UDP. For TCP, it also has the TCP flags in question after that. These connections in particular, this is the machine that I'm presenting on that was trying to get to the WAN IP of the other demo machine on the other one, and was blocking the TCP send. So that means that there was just no firewall rule passing that TCP connection. On any reasonably busy production firewall, you're going to see stuff getting blocked in there that is just out of state traffic, and it looks like something that should have been permitted. We got a wiki page here somewhere that explains it. Yeah, there. So if you see traffic hitting the default deny rule, and it has TCP-F or R or something along those lines, what generally happens there is for some reason one end it said that they wanted to close the connection. At that point, the firewall drops it from the state table, and then the other end either didn't get that, maybe it got dropped on somewhere in between, or on the other side, and then it's the other one still wants to try to communicate and close the connection that it doesn't realize is already closed. So, depending on how busy your system is, you may get a decent amount of that stuff. That's just it's just kind of the nature of things when you're running a stateful firewall. They all do it. Some commercial vendors hide it, so they aren't actually showing you what you're blocking. I'm guessing probably for support reasons, because they may have a difficult time convincing people that those kinds of things just happen and are just a normal part of stateful firewalling.
So we're seeing the destination post NAT on this. Is that right? So first the NAT happens. That's why I see so many internal addresses as the destination.
Yes, you do see this post NAT. So yeah,
Gotcha.
If you are blocking it, it will be post NAT internally. Now, this is just a connection between two laptops I've got sitting next to each other, so they're just legitimately on private IPs.
Mm-hmm.
But
normally you would only see the private IPs and the destination blocked if you had, like, say, 1-to-1 NAT, but you only allowed a handful of ports. Then if something hit a port you don't have a pass rule for, or you have a specific block rule for, the 1-to-1 NAT would still have translated the destination IP, but it wouldn't have been passed, so it would have gotten dropped into the log like you see there.
I see.
Yeah, in that kind of scenario, if we had a 1-to-1 with this internal IP and some public external IP, then this would actually be a public IP. And then whenever you would see this, you'd see, okay, somebody's trying to hit whatever public IP this is translated to and trying to get to it on a HTTPS.
Yeah, I see that all the time because we do 1-to-1 NAT for our asterisk servers.
Yeah.
And so, yeah.
Yeah, some of ours, I mean, there's so much scanning noise on the internet. If you have a decent chunk of public IP space, you might want to create I think I've got on a couple of our colos, I have a no log ports, things that people scan constantly, like the Windows Net BIOS ports, and things like that. Okay, I don't have any Windows boxes by my firewall, and I really don't need 14,000 entries in my firewall log every day if some worm-infected host or some script kiddie who's trying to pop whatever's going on. Same way for like Microsoft RDP. I don't have any of those open, and I don't really care how many times people are scanning me for that. So that's
it's
another
good to kill.
That you may want to do.
It's good to kill like DHCP and then like 137 to 139 and 444, and just to. There's a lot of clever. I mean, if you don't have any SIP, you could just do 5060 as well, because there's a crap ton of SIP scanners that just blast out trying to look for people who have misconfigured PBXs, and they'll charge them 5-digit figures for 900 number calls.
Exactly. I see those all the time. Yeah, it's like, is there a host or is there a SIP client called 1234, 1235, 1236, 1237? Yeah. So.
Yeah, the number of times that they succeed is pretty mind-boggling. We've obtained some support customers who racked up 5-figure USD bills in one day after being compromised. So yeah, that's don't set up like an extension 102 with the password 102. I think that was the last one that I ran into. Man. Yeah.
We set up an asterisk server, and a week later, our legacy Nortel system got hacked with a voicemail forward feature. So I was like totally paranoid that that I didn't know the right things for our asterisk server, and we were going to get hacked. And some fucking old school thing. Excuse my language, an old school thing. They come in, but anyway, we got off pretty clean. So. But the idea of adding an explicit block rule is a convenient way of keeping those particular kinds of things out of the logs, because by default those are not logged. Is that the message?
Yeah, I mean, there are certain things that you might want to see getting logged, but things, if it's no value whatsoever for you to have in the logs, and especially if it's something that spams you continually, like the DHCP broadcast traffic that you'll see here, if you have a system in a data center, a lot of times you'll see the HSRP or the VRRP routing redundancy protocols from your upstream, and that'll put like one log entry a second in there. So, yeah, it's just a general good practice after you put a system in place to just see what it's logging and see how much completely useless noise that you can eliminate from that. So if you do need to look for something legit, then you're not wading through 99% junk.
Yeah. Excellent.
And we kind of have some that's actually gone through pretty well in the firewall chapter of the book. So if you want to kind of get some more thorough examples of how to do that, there's some good step-by-step instructions in there for that. All right. We are way over on time, but I'm going to try to show just one other thing to kind of illustrate how firewall and NAT between multiple internal networks functions. So we'll set up a DMZ on this host, and we'll configure it more or less like a DMZ that you would put servers in, or some people configure like if they have a wireless access point that they want customers or visitors or anybody who's not an employee to be able to access. This is a pretty common type of setup for that scenario as well. I think I'll back myself out again.
As a side note, you can also, on 2.1 and above, we've enhanced the command line version of Easy Rule as well. You could use Easy Rule to add yourself a rule to pass you into the GUI rather than the giant allow all rule if you're in an environment where you think that would not be safe to do. So you could say, like on the command line, Easy Rule pass TCP and then your source host and then the WAN address and then the port number, and it would add a rule to pass you through that way. Of course, that doesn't get you around the block private networks, but
yeah.
But for some people who are building, like, say, a brand new VM, but it's in a live public network, and they don't want to expose everything to the world, just want to get to the management from something that's not, on a local VM network, you could do it that way and sneak yourself in without being overly broad.
Mm-hmm.
So the default for any new interfaces that you never have configured is no firewall rules on that interface. So that means anything that's initiated on that interface is going to be blocked. But anything that's permitted from other interfaces will be able to get through. So it's the same theory in that if you have absolutely no WAN rules whatsoever, your LAN traffic, whenever it goes out, creates a state in the firewall that then allows all the reply traffic back in. That's why it can essentially look like you're not actually permitting anything whatsoever from the internet, but that's just traffic that's initiated from the internet. It's the reply traffic to what you initiate internally is permitted back that way. So I've got that other host that's on the LAN here, and I'm just going to ping that just to show that there are actually. Oh, I disabled the filter, so I have no states. Let me go back and re-enable that. And then once you do, yeah, there we go. If you ever do reset states while you're working on the firewall in your browser and you have a hard time getting the page to load afterwards, Safari isn't too terribly bad about it, but all the browsers are kind of hit and miss, and Chrome is really, really bad about hanging on to old TCP sessions. So if you get stuck, especially if you reset states or kill any kind of states or anything, try a different browser, or sometimes with Chrome you just gotta wait for a half an hour or more to shut the whole browser down. Sometimes you close a tab and open up another tab. Sometimes that'll work. Sometimes you just sit there and hold F5 for, like 3 minutes. It'll finally get the point. But that's a gotcha that.
I have found that if you hit refresh and while it's spinning, if you hit the X while the refresh button is there, and then you go to a new tab and try it, it tends to work.
Really? Wow.
Yeah. You have to stop it while it's actually trying to connect, and then you try it again. Then it seems to be okay.
And only if you're wearing your lucky hat.
Exactly. And if you're crossing your fingers and hopping on one foot.
So here's that host that I've got on the LAN, the .10. I've got a ping going over to the DMZ network. Now, because my test environment isn't cooperating, I don't actually have a host on the DMZ network, but I'm just going to go through and create a pretty typical DMZ rule set in that you want it to be able to get to the internet and you don't want it to be able to get to your internal networks. There are certainly going to be some degree of exceptions to that, depending on the exact requirements of your environment. We'll just do a simple example. So what I'd like to do is just create a network called private networks, and then put all the RFC 1918 blocks in there. Oops. Some people just only use the networks that they actually already have in place on their network, but I much prefer just blocking everything to private networks in those kinds of scenarios, because that way if you add another network in the future, or you add a VPN connection to somewhere else, or something along those lines, you don't have to remember to go back and, oh yeah, I need to block my untrusted network from being able to get to that subnet. You've already got it taken care of.
And a sidebar, that alias works really well in outbound NAT if you want to reduce your outbound NAT rules to only a handful.
Yeah, that's another good idea, yeah. So then you would first add a rule to block or reject traffic destined to any private networks. So for internal interfaces, generally I prefer reject, just because that sends back a message immediately to the source host that, hey, I'm not allowing that. If you don't do that and you're blocking traffic that some application needs to function, that can cause the application to hang up for a long time while it waits for replies. If it kicks back immediately and says, no, you can't go there, then the application will say, oh, connection failed. If it doesn't get that response back, you can lock up applications and kind of cause all kinds of chaos in general. So
some jackass is beating on your WAN. You don't mind if their application locks up, is that what you're saying?
If it's coming in on WAN, it can actually be a problem to do reject, because if somebody's just like pummeling you with traffic that you're rejecting, you're pummeling traffic back out at them.
Yeah, it's like doing half the work in a DOS.
Yeah, it's not a good thing to do on WAN generally.
Yeah.
But yeah, on internal interfaces, usually I prefer reject, because I've seen the difficulties that are inherent in just timing out things with certain applications, especially if you're doing it to user PCs, and you don't want grumpy users, and you don't want to make anything harder than usual for your help desk to troubleshoot.
Is there any plan or any future request to redirect all the block traffic to VM for analysis? Or to any environment?
Not immediately. PF does have a dupe 2 that could allow you to duplicate some of that traffic. Well, you duplicate traffic matching a rule over to some collection point or something along those lines, but that wouldn't do exactly that.
So it's like a mirrored port in a switch.
A bridge on pfSense can have a span port that will get a copy of packets,
cool.
But that would get everything, not just the blocks. And I don't know if you can actually do that for a single interface plus a span port. I'm not sure if that works or not. To where you would just set up, your WAN port and then a port that gets a mirror of your WAN. I'm not sure if that works, or if you have to have the span as a third interface in that bridge. I'm not sure I've ever tried that.
I seem to recall somebody I've never tried it myself, but I do seem to recall somebody on the forum or mailing list at some point who reported they had actually done that, and apparently it works. So, I can't personally vouch for that, but maybe I'm remembering something different. But I seem to recall that that's possible, even though it seems a little weird.
The performance hit using a bridging huge regards to that when you're doing the mirroring the traffic onto two ports or interfaces?
No, it's not. It's not extremely significant. Well, you'd probably be better off doing a span port on the switch if you possibly can.
I have a fiber tap on it, but in case I wouldn't use a fiber tap directly on the cable and a light redirection, then that would be the other choice.
Yeah,
that'll be faster.
Oh, I have that already in the place, so I'm not worried. But I kind of just have it everywhere I want to. Just drop fiber taps and redirect light.
Yeah,
that's the method approved by your friendly neighborhood 3-letter government agencies.
Exactly. We won't mention the DMV by name.
But for block traffic, you may not even really get anything out of actually redirecting the block traffic somewhere, because probably there isn't going to be much in it, at least if it's TCP. I mean, for the most part, a SYN is a SYN is a SYN, and that's the SYN packet is the only thing that you're going to actually block. So in that case, you would get just as much value out of just logging what traffic the firewall blocks, and then syslogging that off to somewhere else.
No, it was more from that if I have a VPN tunnel or a IPsec tunnel or any of those, and inside of that tunnel are running proprietary protocols which are not available to anyone, a part of the two parts, company and another place, then when somebody is hitting all the traffic, I can have a fiber tap on the cable, which also use a decoder and per behavior-based analysis of a traffic, and then using the key to decrypt that traffic and to see analyzing that traffic. So I want to see if I can redirect all the traffic then via ports and avoid using that method for another further analysis.
Okay, gotcha. Yeah, there's nothing that's quite exactly.
All right, it's not a problem.
And then once you reject that, in reality, it would be a good idea to have a much more strict firewall rule set than what we've got here. But just for the sake of example here.
And that PF blocker, the additional package you can install, and allows you to do the top spammer block countries and continents and that scheme. When you apply that to the WAN interface, that's only applied to the WAN address or WAN interface with all the global IP addresses?
So that the way that works is it creates an alias that has all of the IPs from that country there, and I don't think that list has been updated for like a year now, since country IP blocks has stopped distributing any kind of free data that's redistributable. But yeah, generally speaking, it puts that in a source alias and it drops everything from that country. Or if you configure it to put it on an internal interface, it'll drop everything that's destined out to that country.
Yeah. You can look at the rules that it makes and easily tell what the destination is on the WAN rules. If the destination is any, it'll block it to anything. If it says WAN address, then it's only going to block it to your specific WAN IP. But I think that there are options in PF Blocker that control that, or you can edit the rules or things like that.
Yeah.
You can add the interfaces. I haven't seen that I could include in the rule a specific additional global IP addresses which are tunneled to that WAN address, which is /16 subnet, and then whatever else the other addresses are / whatever, I can't remember.
So what I've got here is just the most basic possible thing to don't allow anything to any private networks, but to the internet, hey, let everything go. What do we care? One thing a lot of times I will add above there in scenarios like this is at least let pings get to the interface IP. So echo request any source to the DMZ address in this case. That just makes it easier to troubleshoot if you're trying to figure out if something on that network is trying to reach the firewall at all.
And also if they need access to the DNS forwarder on the firewall as well.
Yeah, that was the next.
Well, yeah. I'll just shut up.
I appreciate keeping it on my toes. And that is generally the way that at least at a basic level of how we set up scenarios like this, where they can get to the DNS forwarder, they can ping the firewall, but they can't get to management on the firewall, and they can't get to any private network whatsoever, whether it's connected via VPN, whether it's on another NIC or VLAN or the firewall or anything else. So that's at least a basic DMZ config. You would probably want to lock down this last rule a bit more, so you're just not allowing everything to send anything and everything out to the internet.
Is there some sort of like a best practices when you do run global IP addresses with the, let's say, or pfSense or in general with the firewalls, that you should rather use one-to-one mappings than assigning global IP addresses directly to machines where you're just dealing with all the global IP addresses, and the global IP addresses are used also for the gateways?
It really depends on your situation, and to some degree a matter of personal preference. Some people do not like NAT at all, but in a lot of cases you are in situations where you really don't have a choice. You have more hosts than you can reasonably get public IPs assigned to you. And in certain software packages really, really, really want you to have the public IP directly on the host. Like cPanel is one that we run into a good deal. So most of the time in co-location facilities like that, what we usually see is a mix. You'll have one, /29 or bigger, usually much bigger, that you directly assign to an internal VLAN, and then you would put public IPs directly on those systems. If you're doing any kind of VoIP at kind of like carrier scale, that's a very good thing to do, because it eliminates a lot of potential headaches whenever you have dozens or hundreds of PBXs behind the firewall. If you add NAT into the mix there, it's just no fun. And then for the cPanel situation I mentioned, that's something you're pretty much stuck with. But by and large, pretty much anything else that you could host is really not going to have any difficulties with NAT. So if you're tight on public IPs, or if your provider is going to charge you a boatload of money to get more public IPs than what you already have, there's nothing wrong with putting NATed systems behind the firewall. Now, it's not necessary at all in the IPv6 world, since there's no scarcity whatsoever of address space. So, in the v6 world, I would not NAT whatsoever under any circumstances there. It's just really for reasons of running out of addresses and the potential costs and pain involved in getting IPv4 address space at this point, which will vary depending on what your provider's policies are.
Thanks.
So in this go ahead. Sorry, go ahead.
Sorry. Yeah, go on ahead.
Oh, I was just going to say, in this DMZ example, in this scenario, say your web servers are going to be in this DMZ. Are your web servers typically bridging to WAN, and the WAN is doing, virtual IP of the public IP address that's assigned to the to the interface of the host and like say the web host and the DMZ, or are you doing like one-to-one NAT typically, and that's and it's how are you typically doing something?
For the most part, it's either going to be public IPs that are directly assigned to the hosts that are on that DMZ network, if you have enough addresses for that, or else it'll be one-to-one NATed hosts or port forwarded hosts. Bridging is a possibility. It's generally less common because it's kind of ugly, and so unless you're in a situation where you have an existing network in place in a co-location facility, you have multiple public subnets all over the place there, and you really can't re-architect your network, but you've decided I really should have put a firewall in between me and the provider before they sent me all these public IPs. In that case, a transparent firewall makes a lot of sense, and there's kind of some different considerations there. Like with a transparent firewall in that scenario, this wouldn't matter because you wouldn't have any private networks. It would be all public everywhere.
A transparent firewall, just that terminology, that just means no NAT, right?
No NAT, no routing. Actually, it's literally a bump in the wire. So you would have like a WAN IP for management purposes, but that's it. None of your other interface would have any IPs at all. And the management IP is, well, it's really actually optional if you don't ever want to get in and manage the system. That's not really a good idea because then it can't sync its time and you can't get in to look at it and things like that. But you only need addresses for management purposes, and then effectively it acts like a bridge or a switch, if you will. It's more like a bridge, but
it's like a managed switch.
It's not actually directing any kind of traffic. It's not changing the source, the destination of it, or translating it, or anything else. It's just evaluating it against its rule set and passing or dropping it accordingly.
So in other words, the all of the interfaces in the transparent firewall would be in the same Ethernet broadcast domain, and each one would be responding accordingly to ARP. But nevertheless, you could still add these rules in between the interfaces.
Yeah, it kind of depends on how you want to do it. I mean, you could have, let's see, you get a firewall with 4 NICs, and you could bridge all 4 of those together. So you would have, basically a filtering switch at that point. Now, if you ever want to push a whole lot of traffic between those devices, that's not a good idea. You want a real switch, but that's a possibility. But you can also have as many bridges as you want, ultimately. And I don't know if there's any really good reason for having bunches of individual bridges, but let's say you had 6 NICs on the device, you could create 3 separate bridges that would be isolated from each other, and we wouldn't even have to know about the existence of the others. So,
I see, because that would compartmentalize the broadcast traffic.
You would have to be careful about what you're plugged into upstream in that case, because if you just plugged all 3 of those in on both sides to the same switch, unless your spanning tree was properly configured, you would just have a layer 2 loop and melt down your entire network.
Yeah.
I don't know what kind of scenarios. We hear so many crazy scenarios that things pop into my head that may not necessarily make any sense whatsoever. But there's probably some reason out there somewhere where somebody might want to do that. But there's a lot of flexibility in what you can do there.
Excellent.
A few quick questions regarding, can you put a pfSense into transparent mode and manage it?
Yeah, that's what I was just talking about. So, you do have to have the one IP to get in and manage it, but other than that, none of the other NICs have to have any.
Can a pfSense or Bean pfSense test it on a 40 gig or 100 gig Ethernet throughput with the high performance server it's running on?
The most that I've seen anybody do is 10 gig NICs, and what you can get through that depends on what kind of setup that you have. I do somewhere I've got
that you have a top of a class setup with the latest NICs you can get on the market, up to date, up to 100 gig.
Yeah. Now we haven't gotten anything at that kind of scale at this point. If you're routing or natting traffic, you're more than likely not going to fill a 10 gig NIC at this point with the current stable releases. Now,
I'm talking about transparency deployment in that case.
Yeah, transparent is much faster because it's not rewriting MAC addresses, it's not rewriting anything in the IP header, it's not writing anything in the TCP header, or the UDP header, or anything else. Some guy sent me a screenshot of a box he's running at a university somewhere, and it's bridging 10 gig wire speed. So it's possible, and it's certainly faster to bridge, since you just have to evaluate the traffic. You don't actually have to change anything within it.
I've seen somebody who had a couple of 10 gig NICs in a lag, but on the inside and the outside, but I don't know that he's actually done any throughput testing on that yet.
That's all right. If I get the chance and I get my new deployment in, then I'll test it and I'll submit something then regards to delay down to nanoseconds. But another thing is, if you put a firewall in a transparent, this is a crazy idea, you put it in a transparent mode on the cable, and let's say your one end failed. Can you have then written a script running on the pfSense which will say, okay, this link is down for 5 seconds, I can't ping the destination address, which is a gateway, so I use a same address and I will enable the VPN link, and then it's like a backup solution of the transparent firewall sitting on the link which should not go down, and if it goes down it has to be automated to switch over to another link and give a same gateway. The IP address of a gateway cannot change in that case because the all other automation is running and using the routing that way. But what change is the way that the link is from physical running of VPN somewhere else.
You're trying to account for the reliability factor of the bump on the wire. You want to basically have a way that it can go backwards through a tunnel because the physical link is essentially broken.
The one side of a physical link. There's way too many points of failure, and despite the fact that they're highly redundant with whatever redundancy you can get, it's still not good enough.
Right. Yeah, like don't put your eggs in one basket, no matter how nice the basket is.
Yeah, but I mean, like these are like even the dual or triple redundant 100 meg or whatever the fiber connection between the locations. It's still two power supplies on the two phases, consistent of two feeds independent. Each feed is consistent of 3 phases, for example, of a power, and that's just the power factor. I'm not talking about other factors.
Yeah, I mean, you can do high availability with bridging. You have to be careful, just because of the possibility of creating that layer 2 loop anytime you got 2 separate bridges going there. And you just got to make sure that in no way can they both be up at the same time. There is a hack in the book. If you look, there's a section about high availability and bridging. There's a script that you can put in there that devd will run anytime that the carp status changes. So if your carp status goes to down, it'll shut down the bridge, and whenever your carp status goes to up, it will bring up the bridge. So that's one way to help ensure that you're not going to create a loop that way, and also making sure you have the appropriate spanning tree configuration on both of your bridges and on your switches. So that kind of gives you, spanning tree is ultimately what you need to prevent that from happening. But
once you have
another layer
one
of protection.
Switch, no? Sorry for interruption. Once you have that on the spanning tree on one single switch in the connection, then that's it. The best thing is to have it enabled on every single switch to prevent that from happening. But once you have a one switch enabled in the chain, that will take care of the looping. Is it?
Not just one. Well, I guess it depends on what's plugged in where. in certain circumstances, having STP on one is could work around those kinds of issues. But generally speaking, that's something that wherever you're going to have redundant layer 2 connections between devices like that you'll want that on every switch that's involved with any kind of redundant connectivity. Really not a bad idea to have it enabled on every switch on your network, because some users like to do really bright things like take one end of a network cable and plug it into the next jack on their desk, like that's going to actually accomplish something for them other than destroying the network, if you know what I mean.
Oh, yeah, no, I work in the dynamic networks with so many traffic generation, and people sometimes he takes out of an isolated network table where it's running a 10 gigabit throughput traffic generation or a 40 gig throughput, and he just plug it in somewhere else, and he just kills the half of the network in a second. Like, the moment he plugs in the cable, everything is down.
Yeah.
Ouch. Gosh.
So, and then when you don't know what was plugged in and NIC was not disabled, or the specific port wasn't disabled, then you go old school, all the cables out and one by one plug in, see which one it is.
Yeah.
Yuck.
Yeah, that's not a fun. We've had some customers call with that issue before, and they have no idea what happened. And I can still get to the WAN side of their firewall to get in and log in and see that they have a billion packets per second of broadcasts on their LAN interface, but trying to help them track it down from there is not necessarily easy. And a lot of times, of course, they don't even know how many switches they have or where they're physically located at times. And all right, start unplugging one switch at a time. Eventually, you will find. Usually they carry their cell phone around. Okay, I'll watch the network traffic on the LAN. You go unplug one switch at a time. I'll tell you when it stops. And that's not a very efficient way to be troubleshooting networks.
Yeah, no, but I mean, like, there are sometimes no other options in that case.
Yeah.
I had this case which there was no other options, and I had to run because there were multiple chain switches, and the biggest issue is that pickup replay, which generate the traffic, or the specific devices for generation of traffic, are also set on the schedule. So your network might be working, and 10 minutes later it just stops, and then it generates for 15 seconds, and then it stops. So in that case, it gets just crazy.
Yeah. All right. We're almost double time here, so we'll kind of wrap it up. For February, I've got a whole list of topics that I know that people would like to see. If there's something in particular that you'd like to see sooner than other things, shoot us an email. We'll prioritize by what you all want to see. Otherwise, or if you have any just ideas in general that maybe we don't have on our list, so I'd appreciate any feedback. And thanks for attending. Not too long after we end the meeting here, I'll upload the slides and the archive of the recording. Once you log in at portal.pfSense.org/members, you'll see it there. There'll be a folder there. I think a folder is the easiest way to get that kind of data into the membership system like that. But you'll see what resources you have available, and there's not that much stuff there, so you'll be able to find it pretty easily if you check back within the next 2 or 3 hours or so. It shouldn't take any longer than that. So.
Outstanding. Yeah, we've talked a lot about logging. Can either of you or anyone make a recommendation for a sort of logging platform that I can, just drop in as a VM, and because all of our routers all over the country are all they're all pfSense and they're all embedded, and so they logs can blow up and fill up this compact flash card and cause the thing to crap out. So I could pipe all the logs to some kind of a syslog server, but
I've been hearing good things about ELSA, and it's included in Security Onion, which has a VM. You could just download a Security Onion VM image or ISO and fire up ELSA on there and point things at ELSA, and it has a bunch of different log collection and parsing utilities.
Excellent.
It's got a web interface and all sorts of fun stuff.
Cool. Is Security Onion an open project, or is that somebody's?
Yeah. It's a Linux-based VM. I can't remember the distro it's based off of. Chris, there's a book we have somewhere. What was the title of that book? That there's some.
Richard Baitlick, his latest. He runs the Tile Security blog. His latest book is on Security Onion in general. Well, it's not necessarily in general, but
something.
He's focusing on NSM, and that's a big chunk of it.
Yeah, it's part of it reads sort of just like an introduction on how to use Security Onion.
yeah,
and
that's
including ELSA and other things.
Yeah, because it's a really good way to get started with that kind of stuff, and heck, in a lot of ways, it's just as good as any other product that you'll find out there. I mean, Richard is the CSO of Mandiant, who just got bought for $1 billion by who was it, FireEye or somebody. I mean, they're one of the biggest names in the network security world out there, and they actually employ the guy who created Security Onion, and actually they run pfSense too, for that matter. They're fans of the project. So here it is. Yeah, the practice of network security monitoring is the book that specifically has some good coverage of Security Onion in general, but also just the process of what should you be doing for network security monitoring, and it a lot of good stuff to consider there. And Richard's a great writer, really knows his stuff. So yeah,
that's awesome. There's nothing like reading a good tech writer. It's just nothing like it.
Yeah.
Is that sort of overlapping with Snort, or is that not the same? It's a different paradigm.
Snort's a piece of it. So yeah. Security Onion does have Snort as one part. So Security Onion is kind of like pfSense in that they take a lot of great pieces that are out there and that are a real pain in the butt to configure and integrate, and they make it really easy for you.
Yep.
It just
you can use it as a collector where you can aim things at it, or you can actually just use it as sort of a passive monitor where other stuff filters the information into it rather than it receiving it directly.
Yep, I see. I just love the idea of just dropping in a VM and just piping in whatever I want to analyze from anywhere. It just sounds just elegant, like what I've been waiting for my whole life.
Yeah. The only nit that some things like ELSA and others have are with our firewall log format. Sometimes the firewall logs from PF come out in 2 lines, but in 2.2 again, we're fixing that. We're actually changing Ermel wrote a brand new log output deal where it reads the PF logs in the binary format from PF and then outputs them in a nice, easy to parse, comma separated format. So.
Nice.
Any parsing, people are going to have to update their parsers, but it will be a really simple update, and it will stay that way until we change it.
If I may suggest, right? I know we're dealing with lots of log parsing and trying to get information out for free as well, especially. So Splunk allows you to do that as well. If you run a Splunk on the Linux machine, you can go up to a certain amount for free, and Splunk would be deployed with the most advanced parsing tools these days, regards to all high-speed monitoring, trading, and stuff. So maybe that would be
Splunk is
also
nice. Is nice too.
You put Splunk agents, and you decide if the machine will be running, or you can pull the data off and over VPNs or anything like that.
Is Splunk part of Onion, or is that just another similar?
No, that's a completely separate solution.
As long as you stay under their limit, I think you're okay.
Yeah, it's pretty reasonable.
Yeah.
If you get over their limit, it gets real expensive fast. But I think the limit's pretty significant, like 500 meg a day or something.
Yeah,
I mean, that's
500 meg is the limit. Yeah, and you can. I'm parsing pickups which are 120 gig.
Oh wow!
Splunk. It's a pretty damn it's a cool tool.
Yeah.
And Splunk is a service, or that's paid software, or because you're mentioning a limit, is that when you say cost limit, is that CPU cost or dollar cost?
Dollar.
It's a dollar cost
it's a parsing
based
cost.
your volume. So you install it on your own server, but then the free version lets you up to 500 megabytes of logs a day, and then if you need more than that, then you pay. I don't know exactly what the number is, but it's like several $1,000s to get up to a gig a day. And then if you're way up there in like Fortune 100 level, where you're gathering like potentially a terabyte a day or something, it's way up into six figures, I believe.
Yeah, I know the people who are paying million plus for Splunk.
Yeah.
So it's really, you have to limit yourself, and you have to know what you do. But when you are smart and you write a really good parsing systems, you will fit in below the 500 meg a day, and it's a lot of data, 500 meg, and especially for firewall logs.
Yeah, you could log. Well, it depends on specifics, but just generally speaking, you could probably log 1,000 average firewalls in 500 meg a day.
Yeah, sounds like it. Yeah, I hope that one day I would have that problem. Outstanding. Is there going to be in the version 2.2? Is there going to be any way to share aliases between firewalls, or share? Because I have lots of times when I have to I have some trusted special IPs that I need to manually enter in between 7 and 13 different places every single time I change something. It would be nice if those could sort of look centrally, much like a centralized DNS lookup, or if even something like aliases could be not just entries in a DNS forwarder, but just something like aliases, or just is there a way to kind of share otherwise repeated kind of things between firewalls?
Yeah, I know what you mean. Of course, it's easy to do across a cart pair, but yeah, you really want to do that across your entire infrastructure in that case. Some people have hacked together things to push stuff out along those lines. We are working on a centralized management system that will be basically the ideal solution for something along those lines. So,
right.
If you don't mind a slow update interval, you could you could put those addresses into a text file on a web server you control, and then add that as an URL table alias, and it will periodically pull and update that. I think our GUI initially limits that to like once a day, but I think I know PF Blocker will do things faster than that, and I think it can pull a custom list like that. But there are other tricks that I've helped people do in cron and whatnot to trick it into updating it a lot faster.
Yeah, but once a day. I mean, that's typical for something that's generally so static,
Yeah, but so it's something like that. You could do it that way, or then there's always, you could add like if you could make a host name resolve to your group of IPs, you could put that host name into an alias and and do a little bit of DNS trickery and get it to happen that way. But there's a little bit more overhead involved, I think, in the DNS doing it that way. But there are some tricks, but ultimately the central management system is going to be the best way to get that done.
Yeah, and in a world of finite resources, I applaud the effort of not spending any time coming up with a half-ass way to do it when a full-ass way is is better.
I have a bumper sticker somewhere around here that says "Be not half-assed."
From
one ass minimum. Go ahead.
From longevity perspective, have you been running like specific platforms on the specific hardware distributions for the long periods of time, and in that way, in the testing environments?
Like in what regard?
Like how long? Like let's say you deploy 9 point. Sorry, it's a FreeBSD. Sorry, 2.1 one version, and since it was released, you have a box with a specific hardware, and that is just simply running that constantly and see if it's going to run into any issues. And plus, there are maybe some QA scripts running on the top of it.
Nothing over a really long-term period like that, just because, generally speaking, usually I don't run into any issues over the long term unless it's that the box is dying. Kind of thing. Usually, it's pretty straightforward to find issues without having something running long term. Our own systems do. We run into systems of customers all the time that they just forget about them and let them sit and run there, and then they want to make some change of it. You go log in and it's got 900 days of uptime, and they've missed 14 version releases since the last time it's been rebooted. But if it ain't broke, don't fix it, I guess. No, I would not advocate leaving a system running that long. But I mean, no. Generally speaking, we never really haven't seen a need to do so.
We decided to. The choice of a pfSense at the company I work for was, start as a trial and see how it works for us, and it worked so far very well. So I'm asking because we would then extend the deployment worldwide as well to most of offices, and we're running specific platforms which we tested so far of specific hardware platform, which haven't yet have a downtime for any reason. So that one we're gonna deploy, I presume, but I want to know if you have run something similar, so I can kind of tell my manager, look, it's okay, they run it, But if you set somebody for 900 days and it's still running, it's fine then.
Yeah, I mean, multi-hundred day uptimes are not uncommon at all. Yeah, and when you were looking at hardware, there are some boxes that are not as good as others. They have cheaper fans in them, and then if the fan goes out, it'll burn the box up eventually, and or they may have cheaper power supplies on them, or things like that. So yeah, I mean there are certain things to consider, and you may or may not be able to tell, unfortunately, in advance of actually buying the box, unless you can really dig in with the.
It also depends on the complexity of the configuration too. If you have a configuration that's pretty light and doesn't rely on much, it's basically just rules and routing. Say your hard drive dies, it could run indefinitely with the dead hard drive until you try to reboot it. Whereas a more complex configuration that might, have like a multi-WAN setup or a proxy, things like that might touch the drive or need to hit the drive to run scripts and update the config and things more frequently, might fail a little sooner if you're running on a dead drive. But there are some ways that can be not fully mitigated, but you can at least get a little benefit from that.
Yeah.
No. The hardware platforms which I would be deploying would be tested by other company, and those platforms are very well tested for some high performance systems, and they would have like 12 NICs and 32 gig of RAM and dual sockets, and that would be the standard of a pfSense what I would deploy on. And all the fans and everything else is tested by that company for a long period of a time, longevity test running. So I would be using that type of hardware, so I shouldn't be worried or be afraid. Then if I know that pfSense doesn't conflict with the hardware I have and it's run fine on all the platforms I have so far, as well as that I have no failures regards to hardware which is not there, then I don't have to worry about pfSense just suddenly drop dead for no reason. If it started working and it's working and the configs are not changed and it's just running and the hardware is not failing, I can expect it to be just simply running.
Yeah, I mean, I think I would get one of the boxes or two of them and put them in some kind of a lab setup and push a bunch of traffic through them. That's
They are already
similar.
They are going to 10 gig, so they're on a gig and 10, but we're looking for 40 and 100 gig, which is going to be this year budget. So I'll be maybe testing that as well.
Yeah, I mean, I think if you run them just all out and just let them push traffic, 24 hours a day for a week, and if they don't fall apart after that, they're not going to fall apart in the field unless the hardware dies.
Yeah, no, that was done already a few times, and they were running for a month even. So, and there was no issues with that. So, okay, no, because I'm going to be deploying now worldwide, London offices and other places, New York probably. So that's why I'm asking. It's just to kind of make my peace.
Yeah. Matthew asked in the chat about a date for 2.1.1. We don't have an exact one, but we're not like adding features or really looking to fix a whole bunch more bugs on it or anything like that. Really, just want to. There's a couple of regressions from 2.1, and from there we'll get it out. Whether that's 2 weeks or a month from now. I'm not exactly sure.
Are there any bridge regressions, like when in bridging, any funky wait states and any bizarre behavior that you've noticed in bridging?
Not that I've seen. Not
okay. I have something to show you this afternoon. Yeah, it crept up, and so the performance issues that I had in yesterday's ticket. The reason I haven't responded is because I was doing some other testing, and I found that by replacing a software bridge with a hardware bridge, with a switch, a number of problems evaporated. Not necessarily the one that the ticket was originally open for, but there's a possibility that I've done something really stupid. But there's a possibility that there's something else.
Yeah, the last time there was any significant change in the bridging behavior was between 1x and 2x, and from beyond there, I haven't seen anything. But I don't have my hands on a lot of bridge configs as much as I used to back in the 1.2 days.
Yeah.
Yeah, I haven't heard of any differences in any of the 2x versions, but yeah, that's
how many users of pfSense are there? Is there supposedly worldwide now? I know it's been growing like crazy.
Yeah, I mean, we can't exactly count users, but the number of known live installs that we can count is upwards of 200,000 now.
Wow. How many were there, like in the what was it? What was the first? What was I'm trying to think what our first version that we ran. We were running like 1.01 or something like that back in. I can't remember.
That would have been like 2006, I think.
Yeah, right. Yeah.
I don't think I'm logged into Google on this machine, but I'd pull up the spreadsheet with the chart, but actually
I can grab it if you.
I think it's on the blog.
If quick questions with regards to NAT and the quality of service. I was reading some people were running into issues when they're deploying a QoS and they're using a NATing. So is there some well-known issues or some sort of things I should watch out for, because I'm just looking into that deployment at the moment?
I mean, that depends on what your goals are and what the specifics of your environment is.
The quickly that's a hard per user base.
Kind of a hard question to answer exactly, without actually getting in. And
I have the graph up here, Chris. The data doesn't start until November of 2008, but at that point it was like 13,000. 21,000 the next month, 22, 24. So it grew quite a bit from there. But I think that was just when the tracking was first getting started.
Yeah, because we used to pull it directly from the CYMRU guys. We pulled it straight from their servers, and then we figured it wasn't very nice to do that as we were getting up to tens of thousands, and now we have 200,000 installs.
Yeah.
Are you planning to implement? Because I'm a gold subscriber, I get the auto backup to your cloud-based system with the encryption on the top of it, which is fine at the moment. But people I would work with or other companies I would work with, they would not be happy. And that's why I had to have that Cisco setup, for example, because their requirements are just crazy off the charts regards to security. And, Cisco has to be a Cisco. Never mind. So, we would like to also recommend pfSense to some of our customers in the regards of if we have a setup between their site and our site, which is sitting behind the multiple layers of security, they would want to have like their firewall settings being backup to their own services, or even if it's to backup to your services with the auto backup configs, then they would like to have some sort of a proof of security standard for that. Those backups are sitting also on the top of encrypted hard drives, and that when, let's say, this hard drive fails, it has to be DoD wiped, and it has to be proven. So I'm dealing with that level of security. So is something like that going to happen in the future, maybe, or?
We've had some kind of similar concerns at points in the past, and those are. If you could send us a list specifically of what the concerns are, we can let you know, which of those are already addressed, or if there is something that isn't, which I can't imagine what that would be. I mean, our data is in a SAS 70 Type 2 certified data center, and it's encrypted and all that other good stuff. So we should be able to cover all the bases there as things stand, but. Yeah, and we could provide a written response for you if you could send a list of concerns.
Yeah, no, I don't want to run into issue with the customers on the main deployments where their traffic flow in between our systems, and they just kind of like, oh no, that's not good enough, and we really love the platform as a pfSense, so we would like to keep deploying it as much as we can. And that's why I'm asking, because when I have to provide to customer something, I need to have a logs of serial numbers of the wipe drives, even, with a picture almost at that level. That's only for the systems which are in between customer sites and our sites, our site. So that is the level. And if I want to use a pfSense box as on our site. For a VPN tunnel, for example, I need to be able to then provide them like, okay, we're backing it up, it's fully encrypted, it's secure, and if it's a cloud-based backup like this one, it's a pain in ours, chasing up that type of level of security standards, providing to them to show them that we're taking care of all the precautions we can.
Yeah, like I don't think you would get like from Amazon or some of those other guys. You could get even like down to the serial numbers of the drives and specific proof of destruction of exactly which drives that data resides.
Yeah, I have a video tapes for hard drives which cannot be wiped, which are taped and scanned before they go to the cycle, which are trashed even to the specific requirements of a size of a hard drive being cycled in the machine. Crashed like to the specific filter, and the square cannot be bigger than 9.9 millimeters. So that's what I'm talking about. Is it something like that possible maybe in the future, further future, doesn't have to be near future, in case we would that's only because there is no feature at the moment that I can send the backup of the pfSense encrypted to my own systems, because it's auto backup, or you have to export it manually, or you have to write the script which export manually and then pull it that way separately.
Right.
So that requires. I have no problem, because I have a team of people who, if I request that, they will put that in the schedule and write whatever I need, like regards to script but. It would be nice to just keep using a pfSense, and maybe then those companies will decide to start using pfSense as well. It's kind of like spreading the good product.
Yeah. Yeah, definitely. I mean, yeah, if you've got a written description of what you're looking at there, if you just want to send it over to supportinfo@pfsense.org, I'll I'll get back to you, and maybe we can discuss that in more detail offline.
Yeah, that's perfect. Thank you.
Okay.
Thanks.
A compelling argument for the use of pfSense, in my opinion, has been that there's lots of different costs associated with any particular technical choice that's made, and one of them is the need to refactor when you outgrow your needs, or when a particular product line is end of life. You have to there's a certain amount of human investment in the knowledge base of use of a particular product, and that's arguably the largest cost component of solutions for most implementations. In an example like yours, for example, you're talking about very, very high-end hardware, so operated by the knowledge base of one human. So maybe that's inverted for you. But my point is that one of the best investments that I've made in terms of my own knowledge capital in my career has been just my Unix knowledge, Linux knowledge is just sort of been consistent and recyclable since day one that I acquired it. Not true of my Microsoft knowledge, my Word knowledge, my WordPerfect knowledge, or even necessarily other more arcane bits of even asterisk coding and things like that. So the point is that it's just such a fantastic investment in your own knowledge base, because it's such a durable solution, and almost no matter what happens going forward, the trend is going to be away from from the need for highly customized ASICs and general purpose GPUs that run on commodity operating systems like BSD. So my point is that it's been an incredibly durable knowledge investment, and so we've been able to stand on the shoulders of this for close to a decade now, and every single time we need to scale up, we just change out our hardware with something more high performance, and we just get to recycle all of our knowledge and all of our even existing configurations. It's just been a real dream. So
yeah, it's. I know. I'm very happy because from insurance perspective, if the product doesn't have support the way you have it, then it's hard to get the insurance for specific things. So that's why a free BSD it's running, or the pfSense is absolutely amazing thing for us, where we can justify that in case in the future we get stuck, we simply go and pay you to get people who works on this platform to fix our issue with no problem whatsoever in case we would run to that type of a problem. And that's why a pfSense is a great choice for even the customers of ours, for example, I would say, and my manager and me are very enthusiastic about this platform. So
I don't care what Cisco or Juniper product you have, what level of support, whether it's gold, platinum, diamond, space dust.
We don't. I can tell you that we don't, because reality is they want to have a Cisco product in between the sites. We deploy it if it's necessary. We're not going to be we're not running to issues by configuring IPsec between two sites and running to any issues. The issues is down the line what is going in the tunnel. And what is going in the tunnel is completely proprietary protocols which are only known to them and us, and that's it, no one else. So, and sometimes we even run to issues where we cannot have a person, and we cannot know as a company what protocol they're running, so we have to send our person to write them some decoder for a protocol on site, which cites all the paperwork which he can't even talk about it. So it's a crazy environment from security perspective. So, and you have to be able to provide those insurance in case, from security perspective, if somebody would breach that and access their protocol, and that's the very important part where we get stuck very often, where the Cisco has to be a choice, or Juniper, but mainly Cisco. So if you want to use not Cisco and want to use, for example, in between two sites, then if we prepare entire plan for them and show them that it's much better, then there we go. We can stop using Cisco and put a pfSense into the place, and then
Yeah, not to mention when you use an open product like pfSense, you don't have to be concerned about nation states backdoors and weaknesses in the pseudo-random number generators and things like that. So that's a very compelling argument.
Yeah.
So, speaking of which, how important is it to have a source of hardware entropy these days in order to have a strong encryption tunnel? I don't know. I know, for example, that this whatever elliptic curve algorithm that was written by RSA, that had a specific weakness injected into it so that the pseudo-random number table was not was more predictable than one might have expected, and the combination of that. I mean, we were always running, until recently when we started using these embedded Lanner boxes, which performed very well. We were using the AMD Geode-LX chipset, which had some sort of a crypto device in it that had an HRNG. So I'm just curious if you have an opinion about whether or not that's a value add. I mean, our particular streams are not so important, but all else being equal, if there's a trivial way to harden stuff, for somebody like us, it's certainly if I can get a HRNG USB key and plug that sucker in, and or if there's some other. I know the hyphen device doesn't exist for, common buses anymore. But anyway, I'm just wondering if you can speak to that at all.
I'm trying to remember what the exact state in FreeBSD 8.3 is, but basically in 10 they've made a good deal of changes in that they never rely entirely on any kind of hardware random number generator. They'll also gather sources of entropy from other parts of the system that are extremely unpredictable. So by combining various sources like that, it's the hardware RNGs probably don't hurt, at least if they're not completely backdoored and we don't know about it.
Yeah, right.
But then adding the other sources of entropy on top of that, it theoretically shouldn't matter if those are backdoored.
Yeah, but I think you're saying that that there's a lot of entropy that can be harvested from the system. You use the word predictability. So even though this is not an unpredictable Windows system, there's enough unpredictability in the system that you can. Yeah.
I don't remember.
There's lots of entropy in my Windows system. That's for sure. Is Chrome going to work today? So. Yeah.
Chris, can I cut in for a minute? This is Matthew.
Hey.
I used to work for Panasonic as a director for a number of years with their IT with Japan. And through their extensive research, they decided to choose BSD as their operating system for a lot of their micro devices. And the reason is because of the vast security and things. And that's what led me to start using your pfSense. And so for all those others that are worried about security, your platform of using BSD is a great stable platform to put a firewall on.
Yeah. Yep, that's exactly why we started out on BSD back in the day, and actually we had been the original co-founder and I had been building BSD firewalls since even way before 2004 when we originally kicked this project off. So yeah, it's very very well proven and good stuff, and a lot of commercial firewalls are based on at least part of BSD license code somewhere. I doubt that there's a single commercial firewall for sale out there that doesn't have some part of code. Some of them actually do run on FreeBSD.
Mm-hmm.
Yeah, due to my age, I lack of that involvement of Linux and Unix because I'm young, and that's why I ask for the longevity tests and a few other bits and bobs. And thanks to Matthews, now it's feel more confident because I'm working with such a system. So thank you.
right. I think I am going to have to cut this short. We're almost
Cut it long,
hour
really.
Cut it long.
over. And,
Less long.
Yes, I'm going to have to cut it long. Unfortunately, I've got to. I'm supposed to be talking to a customer in 3 minutes, so.
You have a live also, it's all right.
Yep. Meeting here. Thanks a lot for attending, everybody, and good discussion and good questions. And we'll see you next month.
Outstanding.
Yeah.
Jim, do you have time for a phone call?
No,
okay.
Past. Yeah, I probably should have left a while ago, but I'm sticking around for this. So.
All right, I'm gonna update the ticket with some observations, and or maybe I should open a different ticket or whatever. I'll put it in as existing ticket. And we can force it.
Just go to see info. We'll check it over. I probably won't be able to look at it till Monday, but
okay.
Different story, different time.
All right,
Talk to you later.
All right, thanks, guys.
Bye.
Cheers.